Okay, this section is actually entitled the number E. What we want to do is see where it comes from. And the way we're going to do this is to investigate how powerful compound interest really is. We're going to invest only $1 at 100% annual percentage rate over the course of a year. And we want to look at what happens to the final amount at the end of a year when we compound more and more. Now what's sitting right here is just the compound interest formula. This actually just comes from what we were doing about a week ago, where you keep calculating rows and just watch the pattern. There's nothing deep mathematically about this, which is really kind of cool. What I'm going to do is try to add a table right there. And what I want to put right here is the formula for investing $1 at 100% interest. So I'm going to go like, I want $1, then 1 plus 100% interest is ours 1. And now we're going to divide by x, x1 actually. That's going to be the number of times we compound. And I'm trying to get out of the bottom here and out of the, like this. And we want to raise to nt. Well, n is the number of times you compound, and nt and t is the number of years. So all we really want here is x1 like that. Now, the idea is if we just put in 1, what we're doing is just letting the money sit there for a year and then looking and seeing what happens. So when I put in a 1 at 100% interest, I better get 2. And sure enough, I do. Yay! Now that says if someone's willing to give us 100% interest for a year and not compound, we'll get $2. That's a lot. But what if they compound it? Remember what compounding means. That means, for example, every month they're going to give me a month's interest on that, and then it'll allow it to grow over the course of a year instead of just growing a chunk by the end of the year. So what I'm going to do is make the number of times we compound 12, so once a month. And we're going to see that instead of just $2 at the end of the year, we're going to get $2 and roughly 61 cents, which is much better than it was. Now, once a month, gave me 61 extra cents. That's 30% extra. That's pretty cool. What if I did it every week? That's 52 weeks. That doesn't feel satisfying. We just compounded 4 times more often, right? And we only got 8 cents out of it. I'm kind of unhappy with that. If I do it once a day, like that, we're only up to $2.71. I mean, that's a lot more compounding. That feels like a lot more work to get not a whole lot of stuff. What do I want? What if I want hours? So I want 365 times 24 times 24. There we go. You can see I do better, right? But here, this rounds to $2.71. This just rounds to $2.72. That's not a whole lot. What if I wanted, instead of every hour, every minute? So this is going to be 365. No, over here. 365 times 24 times 60. It's not getting a whole lot better. In fact, though, you can see that the more I compound, the closer I'm getting to some number. Now let's see if that was every minute, right? What about every second? 65 times 24 times 60 times 60. That's not a whole lot better. But you can see that the amount we're getting is getting very, very, very close to something. Let's try this one more time. If I put in like a billion, I'm not sure it'll let me do that, but let's try. So 1 billion times a year. Nope, it's too big of a number, won't let me do it. What if I let it be 100 million? Nope, still won't let me do it. Let me do 1,000. Let me do 10,000. Let me do 100,000. It let me do 1 million. It let me do 10 million, right? But you can see that even after 10 million, I'm just getting very close to the number I got here. The number that this amount is getting close to is called E, and that's actually the definition of E. E is the number that 1 plus 1 over n to the nth gets close to when n just keeps getting bigger and bigger and bigger. As we compound like nuts, we don't get really, really, really big. We just get very, very close to E, and that's actually the definition of E.